Okay, so I've got my car, my police car, sorry, and I've got it at its intersection. Okay, sorry, going towards its intersection. Now I'm interested in the other car, okay, and at the beginning I put the other car here because that's where the question tells me it is, right? However, I hope you've realized by now, at that point, it's sort of like a meaningless, well not meaningless, but not a very useful diagram, okay? Because the actual situation I'm interested in is after the car is nicked off, it's gone way past the intersection, okay? So I'm going to draw the second car up here. I'm getting lazy. I need wheels. Okay. And the angle I'm interested in, that theta, it still looks relatively similar to what it was before. Okay, there's my theta. All right. Now, here's the crucial difference, okay? Instead of calling this x and this y, I hope you see that's where the problem started creeping in. And in a lot of the questions you've got, right, you don't have any choice as to, you've got to have two variables, but then you've got to get them in relation to each other, right? Except our problem here was that x and y are independent. Because x has its own rate of change and y has its own rate of change, right? So instead of introducing an x and y, I want to call these two distances something else that have just one variable in common, okay? So what are these distances? I'm going to call these distances variables based on time. Because I have to deal with time, right? I've got d theta on dt, that's what I'm trying to find, okay? So therefore, and we know these two sides, their lengths depend on time, right? So how can I express that? Well, let's think about this car, okay? At time 0, which is where the question began, okay? Where is the car? It's at the intersection, at time 0, okay? After time 1, where will the car be? It'll be 60 feet away. At time 2, where will the car be? 120 feet away. And if we wanted to, at time 3, to be 180 feet away, right? And 240 and so on. So if I want to express this distance, the second car, as a function of time, what is it? Well, as time progresses, every time he goes further away, it's going to be 60 feet times the time. So I'm going to call that distance 60t. Now can you see, this is going to be a better way to do things because I have to deal with t anyway, right? So I've avoided this second variable y. Alright, by the same logic, what will this distance be? Well, at time 0, when the question begins, how far is the police car from the intersection? It's 200 feet, right? 200 feet, and then as time progresses, he gets closer, right? So after 1 second, he'll be 120 feet away, and then another second, he'll then be 40 feet, and then so on, right? So it's minus 80t. Can you see that? So built into these equations, you can see if we call this y, dy on dt is 60, isn't it? That's the same rate we had before. And here, if we call this x, dx on dt would still be minus 80. So we've got the same kind of information on here, but just in a way which avoids having more variables, okay? More variables equals more bad, so don't do it, okay? Avoid it where you can. Alright, so now that I've got this, I can actually go directly here. I don't even need to talk about chain rule. That's a bit different, isn't it? I sort of built chain rule into these without having x's or y's. Okay? Because now I can work out the relationship between theta and t directly, can't I? Angle, opposite, adjacent, right angle triangle. Okay? So what's the relationship between theta and t? Well, I guess the ratio I want is 10. Okay, so that's going to be, let's see here, opposite on adjacent, so that's 60t on 200 minus 80t, okay? So I've got a common factor of 20, so I'll take that out. Okay, so there's my tan theta, but of course, if I want to differentiate, I need it just in terms of theta, okay? And then I can work out d theta dt directly. So I just slap a tan inverse on the other side. Okay, happy so far? So now I can dig straight into d theta on dt. No x's, no y's, okay? So if I differentiate this, because it's quite a tricky question, I'm actually going to go ahead and do the, let u equal this and do the substitution just so I can work out what it is. So I'm going to say, before I get to d theta on dt, I'm going to say let u equal 3t on 10 minus 4t. Is that okay? That implies that du on dt is, quotient rule, I can't avoid it yet, u, v, I'm going to get v times u dash, which is just 3, minus u v dash, which is minus 4, all over v squared. Okay? So you can see why it's worth doing the substitution, because I do not want to do this in my head. Okay? I'm going to get 30 minus 12t there, and then conveniently I've got plus 12t here. Okay? So my t's are going to cancel. Here's my du on dt. Okay? Du on dt. Now, if that's what I let u equal, therefore my function for theta is theta equals tan inverse of u. So what's d theta on du? Do you remember? Tan inverse. This is the one without a square root in it. Okay? So this is 1 over 1 plus u squared. Okay? So I ended up having to do chain rule anyway, but not because of different variables per se, but because it was a messy kind of function. Okay? So what I was really after was d theta on dt, which is, here's my chain rule. Okay? So here, because I don't actually want u's at all, I'm going to get rid of my u and sub it back for what I had before. Okay? So this is going to be 1 over 1 plus that's my d theta on du. Here's my du on dt. Okay, and here it is actually in our interest to multiply this out because it'll make this denominator simpler. Get rid of our fraction. Okay, so I've got 30 on the top. You happy with that? Is that okay? Yeah. Alright, now I suppose I could simplify it a little further because there's going to be some like terms that can combine here, but I think at this point it's simple enough for me to actually start to solve the question because I was interested in a particular point in time, namely when t is equal to 2. Okay, by the way, before I go ahead and work this out, you just have a look at your result here for d theta on dt and does it make sense? It's positive, yes? So therefore, the angle is increasing over time. Does that match what you would expect? It does, right? Because as that car races off, and as this one gets closer and closer and closer to the intersection, this triangle is going to get sort of thinner and thinner and thinner. So this angle theta is increasing. Okay? Alright, so now I can sub in. Okay, so I've got d theta on dt, which is equal to 30 over. Okay, what do we got? 10 minus 8 all squared plus 9 times 4. Minus 4. That's 30 over 4 plus 36. That looks like 30 on 40, which is 3/4. And of course our units is, it's an angle, so it's radians per second. Okay? And you would conclude that on the bottom. Okay? Okay, exhale. Now, this is not particularly pleasant, partly because what we got for theta and t was not nice, so we had to be careful with our chain rule here. But it is better than bashing your head against the brick wall and trying to work with your x's and y's, which eventually there are ways to work with, but it'll be 5 times longer than this. Okay?